Okay, number 3 says a real number theta satisfies cosine theta equals tan theta. They're not asking me for theta, by the way. They're just saying there is some number that satisfies that equation. They go on to say, what's the value of this thing over here? And I think I can do it. And I'll go to the whiteboard, and I'll tell you what's given. There is a theta that satisfies this equation over here, but they're not asking me to do it, by the way. So this is number 3. And I'm going to say this is a given, that the cosine of theta is equal to the tangent of theta. And what I'm going to do over there is, I'm going to maybe manipulate it a little bit, and I'm going to say that what I normally do is write tangents in terms of sines and cosine. So sine theta over cosine theta, that's what tangent is. So cosine squared theta would be sine of theta. And by the way, there's some real number theta that satisfies the equation. So what I want to do now is, what do they want me to do? They want me to, what is the value? Let me write this over here. They're asking me this over here. 1 over sine theta plus cosine 4 theta. They're asking for that, all right? Now the question is, I don't know what that is. So I'm going to use this to try to figure out what this is. And the way to do that, I guess one thing I could write down, now look at this, step by step. I got to think through this, don't I? Well, you know what? I know what the cosine of 4 theta is, and that's going to be what? The cosine, I'm using this up here. This is so important. I'm using this to do that. So the cosine 4 theta would equal sine squared theta. So write that down, sine squared theta. All right, I'm looking at this 1 over sine theta. I don't want to go to secants, by the way. I could, but I don't want to do that. So I'm going to take the 1 on top, and I'm going to write it in terms of sines and cosines. So I'm going to say it's sine squared plus cosine squared. And that's over sine theta. It's the same thing, by the way. So this is leading to that. I'm looking at that now, wondering what to do. And I got something. Well, you know what? I know the cosine squared of theta is sine theta, so I can write that down now. So sine squared theta plus the cosine squared theta is just sine theta. And this is over sine theta plus sine squared theta. So you notice I'm getting everything in terms of sines now. I'm not sure it's going to help me, but I can go through it. And what you have there, I'm going to divide through the first term. Sorry about that. That's going to give me sine theta plus 1. Again, that's the first term, by the way, I just did. So sine squared divided by sine is sine theta, and sine divided by sine is sine. And it's going to be sine squared theta. All right, I'm looking at this and wondering what to do now. Let me take a look at it. Oh, you know what? Sine theta is cosine squared theta. Write that down. Plus 1 plus sine squared theta. Now what do I know now? I know cosine squared plus sine squared is going to be 1, and 1 plus 1 is 2. And this is one legit way of doing the problem. I got 2. I want to talk about another way of doing the problem. All right, so there's another way of doing it. And let's go through that over here. It's a numerical way. And I'm going to do this as cosine theta, is equal to tangent theta. It almost looked the same, by the way, but this is going to be numerical in form. And the cosine of theta, what I did before, sine theta over cosine theta. And then I'd write down cosine squared theta is sine theta. And then I know back from my pre-calculus days that I want to write everything in the same function, which is sine. And cosine squared theta is going to be 1 minus sine squared theta. And that's sine theta. Wow, this looks tough. What do you go over here? Sine squared theta plus sine theta minus 1 equals 0. I'm going to use quadratic formula to solve that. And theta or I'm showing sine theta, sorry about that. I'm not going to solve for theta necessarily. Is going to be this quadratic formula. I'm going to get a 2. And then I'm going to get, let's see, I got to think about this. Because this is quadratic in sines. I'm looking at the coefficients over here. So it's going to be -1, plus or minus. I'm using quadratic formula, by the way, to solve for sine theta. Sine theta is like an x in the problem. And then I get what? I'm going to get 1 minus 4 times 1 times -1. And what do you get there? You get -1 plus or minus. This is going to be what? That's going to be 5, right? Let me make sure of that. I get 1 plus 4 is 5. Yeah, that's pretty reasonable. And this is sine of theta. I got troubles over here. I want to point out the troubles I have. I have 2 numbers. And that's going to be -1 minus the root of 5 over 2. Or the other number I get is -1 plus the root of 5 over 2. And it's time for me to think. I'm only going to say that I'm looking at this over here, and I'm noticing that this guy over here is not going to be possible. And the reason for that is, the square root of 5 is, it's 2 point something. So on top I get a number, you get like -3 about, and that's certainly bigger than when I say bigger, magnitude is bigger than the -1 below it. So there's no real theta for this one. But this one looks okay, all right? So I'm going to say sine of theta is going to be root 5 minus 1 over 2, all right? And then someone says, what are you going to do with that? Well, I'm looking back what they want, and they really want the cosine fourth, don't they? So I'm going to write down sine squared now, because that's going to get me to cosine squared eventually. So I got to square this thing over here. That's 4 in the bottom. When you square the top there, you can get 5 plus 1 minus 2 root 5s. Let me keep going along with this. So sine squared theta is going to be equal to, this is going to be 6 minus 2 root 5s over 4. And the sine squared theta, I'm going to divide by 2, by the way. 3 minus root 5 over 2. All right, we're well on our way to getting cosine squared now. Let's write this down. Cosine squared theta is going to be equal to 1 minus sine squared theta. Well, I can write that down. 1 is going to be 2 over 2 minus, this is going to be 3 minus the root of 5 over 2. And it's going to give me 2. And what do you get there? Well, you get 1. I got to be careful now, right? That's going to be 2 minus 3, which is minus 1. And then you get plus root 5. All right, let me write this over here for you. So root 5 minus 1 over 2 is cosine squared theta. All right? Wow. What do I got to do there? I got to square that. So it's cosine 4 theta. That's going to be 4. When you square the top, you get 5 plus 1 minus 2 root 5. What does that give you? 6 minus 2 root 5 over 4. And what do you get there? You get 2, I'm sorry, not 2. You get 3 minus root 5 over 2. Okay, so we have 2 things, but we want what? We want 1 over sine theta plus cosine to the 4th power of theta. Well, I know one of them, I'm staring at it, and that's going to be plus, that's 3 minus root 5 over 2. But I got to go back and remind myself what sine of theta was equal to. It's equal to this. So I'll put the reciprocal down, and what's the reciprocal going to be? It's 2. Let's go back over here. Root 5 minus 1. Well, I got some work to do, don't I? And the work's going to be a common denominator, 1. And the common denominator is going to be 2 root 5 minus 1. And what do you get there? You get 4 plus root 5 minus 1 times 3 minus root 5. Wow, it's much more complicated than the other method, wasn't it? On bottom you get 2, root 5 minus 1. On top you get 4, plus, well, I got to do this, 3 root 5s, minus 5, I'm distributing by the way, minus 3, plus root 5. Let's kind of pull things together. And it looks kind of complicated, doesn't it? Minus 5 minus 3 is minus 8. Minus 8 plus 4 is minus 4. Let's see, minus 5 minus 3 is minus 8, plus 4 is minus 4. And this is going to give me 4 root 5s. And that's all over 2 root 5 minus 1. What do you get there? Factor of 4 out, and you get root 5 minus 1 over 2 root 5 minus 1. Lo and behold, they cancel off. And 4 divided by 2 is 2. Are we still getting the same results? We are. So regardless of the method we take, we're getting a result of 2. And we're done. Thank you.